All right, we're doing our first algebraic proofs today. You don't realize it, but you have already done proofs. Whenever you've learned to solve an equation and you've solved it and you've gone through the steps, you have been proving the answer. Okay, so you know what the steps are to do those problems because you become very good at solving equations. But now you're going to have to formally explain what you do to solve it. So we're going to do algebraic proofs today. Actually, we're going to add in a couple of segment proofs as well. A list of algebraic steps to solve problems where each step is justified is called an algebraic proof. The table shows properties that you've studied in algebra. This is the table we're referring to, and it's on your paper. The addition property of equality says if A equals B, then you can add the same thing to both sides and it will still be equivalent. You've done that before. The subtraction property, likewise, if A equals B, you can subtract something from both sides and it will be still balanced. The multiplication property, you are allowed to multiply both sides by something. You can divide by something, division property. These are all things that you use when you solve your equations. Then there's a couple new ones, so we're going to kind of highlight those. The reflexive property is a new one, and it's kind of just very straightforward. A equals A. It's when you say something equals itself. And there are times when you need to do that in our proofs. So it may seem like, and we're just going to have to learn to identify what property is being represented. Symmetric property is another new one. The symmetric property says if A equals B, then you can flip it around and say B equals A. What the purpose is of that is, when I've talked to you earlier, I've told you that it didn't matter to me when you're solving an equation what side the x was on, right? Or the variable. So sometimes we got something like it said 6 equals x. And I told you it didn't matter. That was okay because by the symmetric property, that still means the same thing, that x is equal to 6. Okay? So it didn't matter what side your variable ended up on when you solved. So that's a way to use the symmetric property. The transitive property, I like to do a counting system to help you identify that one. This is also one you haven't seen before. Transitive property says if you have one thing equal to a second thing, and that second thing is equal to a third thing, then you can say the first one and the third one are equal. Kind of see the pattern there? You drop the middle term. And then you can say the first and last are equal. The substitution property may be new for you. Substitution property is if A equals B, then you can replace A with a B in any equation or expression. It's like making a trade. The distributive property you've used over and over and over again already, where you multiply it out through the parentheses. So we're going to be using those properties today to prove equations. And that, I don't know why we have a second page that's the same, but there we go. So, I don't know why this didn't work for me. It didn't go away. We do not want to see those little men right now. He's not supposed to be out there. I got to put him back so I can explain this proof. We're going to solve equation just like we normally would, except this time we're going to have the explanations in there. That's what a algebraic proof is. So the first thing you do is we put down the thing that is given. They're telling us to solve that. That goes in the first line. And that's because they gave it to us. This has been given. And that was what that little man had. He was pulling out the word given. So we're pulling out the reasons for being able to say what we've done. What would be the next step if you were solving this problem? Anyone? Add x to both sides, right? So we're going to add x to both sides. So what we're thinking in our head is add x to each side. So we put it in the blanks. Now, normally we don't write it like this. I know I haven't been having you go in a horizontal line like that, but just for the sake today, we're just trying to learn this. I won't make you do this later, okay? But what we've done is add x to each side, which is done by the addition property. Since we're adding the same thing to both sides, that is the addition property of equality. It doesn't We're allowed to do that. And that's what he's holding on to there. Okay, for the next part, we would simplify this by combining the like terms. And we do 2x plus x is 3x. So we'd have 3x plus 3. And on the right-hand side, all we'd have left is a 9. Okay, and that's just combine like terms or simplify. I'm not pulling him out because this year I've decided I will not be using the word that the text does. We're just simplifying it. The next step, what will we do now? We'd want to get rid of this. Yeah, so we're going to subtract 3 from each side. And that would result in, and I'll let you do it right here. Yeah, we'd have 3x equals 6. And what did we do? We subtracted. So that's just the subtraction property of equality. So you write subtraction property in the blank. I will be abbreviating some things at some point. The next step, we would in our heads to go, okay, well, we got to divide by 3 on each side. And then we would write the solution of 2. And that would be because we divided. So the reason that we got to get to this step is the division property. So that would be your last reason. Okay. So we're doing first algebraic proofs before we do geometric proofs, because you're familiar with algebra, and this will make some sense to you about why the process would be this way. Is this your next one, right? This guy's just being a pain. He's being a pain. Go away. He won't let me get rid of him. Oh my Lord, what is that? Why is that doing that? Sorry. Oh. I can't get rid of him. Okay, I just can't get it to work. So I'm sorry, I'm just going to have to do it. Let's fill in our blanks. Escape, mister. I'll just leave him alone. Rewrite the original equation. This is not the same. This isn't on your paper. I know it's not. You've got this, right? You have solved this. So I put that in the first box. That would be your given. The next step would be to do negative 24x minus 8 equals 64. We multiplied, but it's really called not multiply, but distribute. That would be your distributive property. Okay, and then after we would have distributed, you would have added 8 to each side. And that would have given you negative 24 times x. And that equals 72. And that would be by the addition property. And then finally, we would have divided by negative 24. You can show that if you want to on your paper. You don't have to. And you would have given me the answer negative 3. X equals negative 3 by divide by negative 24 on each side, which is dividing, so you have the division property. Not all that bad. Okay. In geometry, a similar format is used. There's 2-column proof or formal proof. 2-column is what we were just doing. You get your statements and your reasons organized in 2 columns. Each step is called, and you have to provide a property for each step that you call out. So geometry deals with numbers and measures. So geometric proofs use properties of numbers, and here are some of the algebraic properties used in proofs. So what you might see when you're doing a geometry proof, and not just an algebraic proof, is segments and distances and angle measures, etc. So for the geometric properties, when you want to use reflexive property, you might say that segment AB equals itself. And that would be like because you were trying to prove some triangles congruent or something. So we're going to be doing that later. we're going to be doing triangle proofs in the future. And see how this segment is shared in both of the figures? So you might need to say AB equals AB, okay? That's what I'm talking about. So I'll be teaching you how to use that going forward. You could also say some angles where it's the same angle in the figure. So you could say angles that are congruent. I don't like that angle symbol there. That looks like a less than instead of an angle. The symmetric property, flaps it again like it did before. You can do that with angle measures as well. And the transitive property, maybe saying distance A to B equals C to D, then C equals EF. Just like that. 1, 2, 2, 3, 1, 3. Can we stop snapping that, please? Thank you. Now, this little arrow here did it again on me, and I've obviously got a little problem with my technology here today. The point being, let's talk about this as a little segment proof, or it has angle measures actually, not segments. It says the measure of angle 1 equals the measure of angle 2, and that was given. So I'm going to mark it on my picture. That's going to be an important concept in here. Angle 1 congruent to angle 2. And then from there you could say, well, I got another given. The measure of angle 2 equals the measure of angle 3 is given. And so I mark that on my picture. And then I say, well, I can see 2 and 3 are congruent, but there's a property. See the 1, 2, 2, 3, 1, 3? That's the transitive property. That's why that was there. Whoosh, put it in there. Okay. Next thing I'd like to go over with you. I know I went backwards instead of forwards. Now we're going to practice identifying the properties. So maybe you can help me out with that. It's really not the time to throw things away. State the property that justifies each statement. The measure of angle 1 equals the measure of angle 2, then 2 equals 1. Okay, is it transitive? Are there 3 things here? There's not 3 statements. Can't be that. Is it symmetric, which means you flapped it? Yes. Okay, let's see if you guys can identify these. If the measure of angle 1 is 90, and the measure of angle 2 equals the measure of angle 1, then the measure of angle 2 is 90. Oh, I love it. Who said that? Wait. Substitution. That is the correct one. Now, some people might have thought it was transitive. Let me explain the difference. Very good. The measure of angle 1 says it's 90. You got 2 and 1 being equal. And then they went and they took the fact that 1 is 90 and they traded it for that to come up with this. You see it? So they did make a substitution. The next one, I see AB equals RS, RS equals WY, so AB equals WY. The middle thing matching and dropping out, that's the transitive property. Now, if you think about it, isn't transitive sort of like making substitutions? Very, very similar. So when I actually am trying to assess your knowledge of this, I pretty much make it clear it's going to be the transitive, very much so, but I almost always will accept those kind of interchangeably because they're so similar in some ways. So we'll talk about that in proofs later. Now, what am I doing here? Am I doing substitution? Am I adding or multiplying? It looks exactly the same, except we have, maybe you're thinking that looks more like division to you, taking half of something, but we're actually multiplying a half times those, so this would actually be multiplication. And all you had to write down the property. I know you did not have these choices. I was just giving you options. Maybe need this page still? Okay. All right, so we got some more to identify. Let's see if we can do it. The measure of angle 1 plus the measure of angle 2 is 110. Angle 2 equals angle 3. So the last statement is the first statement with a replacement, which means they made a substitution. What was done is angle 2 got replaced with angle 3 to get that third statement. Okay, so they made a substitution. Feeling okay on that? Well, what is this? RS equals RS. Well, duh. But that's, yep, that's that special reflexive property. And then let's see what this one does. Oh, this looks like it might be coming on to be a transitive, but it's not. And I didn't even give you that option. AB is equal to RS and PU is equal to WY. Then they went and took this and added it to that, and they took this and added it to that and made this. These guys were equal, so they added something equal to both sides, which is, yep, it's addition property. And then number 8, we've got the measure of angle 1 equals the measure of angle 2 and angle 3. Oh gosh, I see a 1, 2, 2, 3, 1, 3. Yep. Now the next part is says homework, but there's a couple of problems I would like to do with you guys. Yes, sir. You need to go back. How are we doing? All right. Okay. In the homework, I want you to do 1 through 5, but I'd like you to skip over with me to do a couple of these problems. I think I have a line here that I forgot to take out. I've been trying to make these more concise because I felt like the way we were doing them last year and a couple of years that it wasn't the best way. So I might have something to adjust on here. Let me look at this just for a second. Yeah, I think I need to take out a line. All right, let's just go for it. This first one would be the given. Then we have subtracted 2x from both sides, and that would be the subtraction property. We would combine our like terms and get 6x minus 5 is equal to 1. And then I really wasn't expecting you to have to write this line because I don't normally make you do it. I tell you, you can write it underneath here. You know what I'm talking about, where you would write plus 5 on our next step, which would be by addition property, and you would already get it to here, right? So what I'm trying to say is I don't like this step being here. So if you would just completely cross out 4, because I don't want you to have to write that on the line. I know you're going to be thinking this. You're going to be going plus 5, right? And then you're going to drop down and you're going to write 6x equals 6. And the reason you went from here to here is because you added 5. That's where I want the word addition. That's where I want addition property. So each time you do it, your step, what you did to get to there is what you put on the right-hand side in the reason column. What would be the next thing for us to do? All right, so your next reason is division. You're doing division property to get to x equals 1. You want to show it like this? You may. You don't have to. Okay? All right, there is another one that I've had students I know will maybe struggle with a little bit with. It's this segment one here. We're going to do this one together, and then we're going to go and do one more, and then I'm going to let you work. So this has got multiple choice on it. I'm just going to really try to go through the proof, and you can use these as your clues that we're going to fill in. So what would be the first thing we would want to write down based on what I've said so far? Yeah, what's right here, this one. Is there something over here that matches that? Segment PQ is congruent to segment QS is J. I'm still going to write it. I'm just going to write it out. Segment PQ is congruent to segment QS, and that's choice J. And that was one that was given. So I'm going to go ahead and cross out D, the given. Now, there's another thing given, so I'm going to put it next. Segment QS is congruent to segment ST. I'm going to find that over here and cross out. Oh, that's E. I'm going to cross that one out. And then I'll write given, which was G. And now I've taken care of those four. Now, looking over here, I see some QSST equal, I see PQ equals QS. Oh, I think they're trying to get us to say that PQ equals QS next. And after that, that QS, and they're dropping that bar and making an equal sign. Well, why? And it's because your book, this book, likes to do things a little differently than I used to do in another book when I taught here many years ago. We had a different text. It can make you do some of these steps, but I think some of it's good in that I want you to understand that this is talking about segments, and these are talking about length. If the segments are congruent, then they have the same length. That's what the definition of congruent segments is. So that's the thing that goes in these spots. A would be definition of congruent segments. You can write segs, and I abbreviated definition with F. I used to always write a little N up here, but next one would be F, which is another definition of congruent segments. This will come up often, definition of congruence. I don't have a whole lot left here to do. What was my goal in the first place? I forgot to cross some of these off. My goal was, let's see, to prove PQ equals ST. This is the goal. It is what goes, it goes last. So it should be on the last line that PQ equals ST. And then we think about what we had up here. We had PQ equals QS, QS equals ST, so PQ equals ST by the transitive property. That one was I and this one was B. But you don't really have to have those alphabet letters there because I just as soon see the proof filled in. The other one that I'm leaving number 9 for you to do all the way. This one, this way. Get to, I wanted to go to 18, please. I have realized this year, and it's not happened to other years, this is the first year that some students are doubling up in their math this year. I have a lot of sophomores that are doubling up and taking geometry and algebra 2 right now so that they could be in chemistry. I believe that was the motivation. How many of you are doing that? Algebra 2 and Geo right now. Wow, you've got a lot of homework. A lot of math homework, right? Yeah, but good for you. I have quite a few in my other classes also. But the reason I mentioned that was because I'm thinking that my students that are just taking algebra geometry right now probably don't remember what the first step is that we're trying to get at in this problem. Okay, that's why I chose to come to this one. So let's write down the given, which was 1/5 x plus 3 is equal to 2x minus 24. Now, what would you do to this equation? So it would become x plus 15 equals 10x minus 20. I know a bunch of you can think about that. Okay, kids? Very good, yes. What they're doing, and now that maybe you do remember that from your Algebra 1 class, when you did have fractions, your teacher may have taught you how to clear them out. Okay, so the next step right here, what they did was multiplied by 5. So 1/5 times, I'm going to put 5 in a parenthesis, 5 in front of a parenthesis with 1/5 x plus 3 in it. And on the right side, I'm going to do the same thing. 5 times 2x minus 24. So by the multiplication property of equality, we can multiply both sides by 5. And when we do that, we're going to distribute the 5. That's how you're going to get x plus 15, which is what Cadence saw. 5 times 2x is 10x. 5 times minus 24 is minus 120. So what did I just say we did? What was the rule for what we did to get here? Distributive. We use the distributive property. Okay, the next step, I know you would want to get your x's on one side. So since x is on the left and 10x is on the right of the equal sign, I think we would subtract x. So we're going to take away an x from both sides by the subtraction property, which will give us 15 is equal to 9 times x minus 120. Okay, and what are we going to do next? What would you do next so that we get 135 equals 9x? Yeah, add 120. So that would be by addition property that you got there. I'm not going to be giving you a big old blank thing and making you fill the entire proof out. It's going to be these kinds of problems where you fill in blanks. I'm going to lead you a certain direction, and then you're going to fill in the blanks. All right, so now we got 135 equals 9x by addition property. Next step by division would give us the answer of, now we would divide by 9. Can someone do 135 divided by 9? All right, 15, right? But you got 15 equals x by division property. And then you can turn it around by the symmetric property. Yeah, so x equals 15. That's what I was talking about, how you can use that when you get the variable on the right instead of the left. Pardon me? I agree. I understand what your point is, okay? And that this is a little bit of, we're pulling out from you to get you to try to understand these properties and why it's okay that it doesn't matter what side the variable is on. It is, there's some steps that I think that are a little, we don't actually have to have. Personally, I'm fine with someone solving it and not doing this turnaround, but I'm trying to teach you how to use the properties. Okay, so we're just going to hang in there. All right, that's all I'm going to do that I planned on doing with you. I'd like you to work on your assignment now for the rest of the period, and I'll come around and help. Unless you have a question right now. Yes?